Hey guys, welcome back. It's Brandon and Aspen once again, and here we are for experiment 3. And for experiment 3 is, since Aspen already spoiled it for you, is we're going to take experiment 2, add the amplifier from experiment 1, and then we're going to see how the output sounds compared to what you had just a moment ago.
It's going to be awesome.
Yeah, we tested it. It works. And we know it works. So if you remember from experiment 1, how we built this nice 2-stage amplifier out of resistors, BJTs. We used the function generator to test it. We had the speaker as the output. Everything worked great.
Right.
Well, essentially that's what we're going to do here. So we're going to draw you real quick just a real simple, basic circuit. And if you refer back, actually, if you'll see in your lab manuals, you'll see the circuit in your lab manuals, but we want to go ahead and show it to you anyway. Right. And we want you to understand where the amplifier is going to go in our light amplification circuit. So let's go start there. We'll start on the speaker and solar cell side.
Yeah.
And then we'll go back and show you the, well, not the amplifier part, but we're going to show you the LED part, which was the simplest part of it all. I mean, if you can remember that,
halfway there.
Yeah, literally, because there's 2 halves to this circuit.
Right.
So here we go. Oh, wiping out all of Aspen's lovely handwriting.
I know, this is just terrible.
That's your part. I can't reach all the way over that table.
You're right, bud. Okay.
So essentially what we're going to have here is we're going to have our nice little solar panel. Just roll with it. I'm not going to draw the nice little nifty lines that Aspen did. Like I said, we're going to keep this real Mickey Mouse. Actually, you know what? Let me change colors here to make life a little bit easier on us. So our solar cell is going to be the input to our amplifier. So right here, we're going to have the positive side of our solar cell. I hope you can see that positive. If not, my apologies. Needless to say, this red's going to be the positive. And the ground of the solar cell is going to go, the negative of the solar cell, I should say, is essentially going to go straight to ground on the circuit where everything else is going to be grounded. Everything's going to share ground. You'll see later as we put the circuit together, that's where we'll be. So essentially, the first thing you're going to run into is that first capacitor, and then you're going to run into the base of our BJT. And real quick, I'm just going to put this right here. There is a resistor that's going to go above it, and a resistor that's going to go below it, and a resistor, 2 resistors that are going to go right here. So we'll have our first resistor, and there's our ground.
Right.
There's our other resistor that goes up to our biasing voltage, if you remember what the biasing voltage is. Biasing voltage we need to make the circuit work the way we want it to work.
Pretty much turns on the, what we're going to do is going to make sure that the BJT acts the way we want it to act and amplify, you know, it's going to amplify our input the way we want it to. Okay.
Yep. So we're going to put X right here for our voltage, because this time around what we're going to do is we're going to connect our circuit to one of our varying voltage supplies, because we want y'all to listen what happens as you change the voltage bias of the circuit. So if you remember, there's our second capacitor also going to ground.
Then that goes straight into our second BJT here. Yeah, that should be. The connection from our collector part of our first BJT is going to branch to our base, to our second BJT, which branches right here. And then we again have our voltage at the top, our varying voltage that goes straight to the collector of our second BJT, and also to the capacitor, and straight to ground, parallel to the collector part. And then our emitter, when you go down, connect to the emitter, and we have a resistor to ground, and then parallel to that we have our capacitor which will then also be inserted to our speaker, right? So with Brandon's joint right here, you get to see it. There you go. Okay. So yeah, so if you can imagine just the 4 resistors, the DC input, and the function generator input to the left of the solar panel, this is what you're going to have after the solar panel. So as you can see here, the difference between experiment 2 and this one is that we just have our amplifier in between our solar panel, our solar cell, and our speaker.
Right. So essentially, every place you see this little symbol right here, that's all going to be sharing the same. Well, okay, not up here, but right here, here, and all here, that's all going to be the same ground. So Aspen is going to redraw our LED circuit for us. How about we get you some prettier colors than our little just red and black?
Of course.
And just keep in mind, of course, I drew this over here. Aspen's drawing that over there. Just keep in mind that your LED, when the time comes, has to be shining directly at your solar panel, or you aren't going to get anything. It's just not going to happen.
Of course. So here, what I'm going to do is, this is our DC voltage source here, which is our battery, right?
Right, because we're still going to use 9 volts on this, because the only thing we're going to vary here is just going to be the function generator like we did last time. So essentially you're building the same circuit from experiment 2 for the broadcast side of it. Unlike experiment 2, there'll be 4 resistors in series in order to get that done.
And remember, our resistance is 400 ohms on this part of the circuit. And then of course our LED will be on, shining a light, which is bright white, as you saw earlier in experiment 2. Okay, so like Brandon said, like I said here, this is going to be our audio input right here. Okay, you can count this whole thing as our audio input. Okay, because the light that's going to shine onto our solar panel, our solar cell, that's where we're going. That's when we start amplifying what you like. The small sound you heard from the speaker at first with the LED. We're going to amplify that sound, and that's what you're going to hear at the end of the speaker now.
And when it comes time, you're not going to hear a nice, crisp, clean sound out of it like you heard. I mean, if you did hear anything coming out of your experiment too,
yeah.
It was real faint, but it had a clean sound to it. This time you're not going to have a clean sound, and the reason being is because remember how this experiment worked where you had the constant voltage and then the frequency generator would increase it as the sinusoids went up and down? Well, because we're cutting off part of that signal, that's where you're going to hear a slight distortion of it because it's losing part of that information it needs. Your brain puts that information in there whether you know it or not,
right.
But that's where you get the distortion from. So let's see here. Yeah.
Yeah, that's pretty much is it. May look like a lot, but it really isn't. Okay. We're going to show you how to construct it onto the circuit board here in a second, and then we'll see our results and you guys have a little bit of fun with it.
Yeah. And don't forget to refer back to Lab Manual Experiment 1 for all these values. We have them all listed there. In fact, in Lab Experiment 3, we also have them listed here as well. If you just have any questions about it, Lab Experiment 1 is going to have the most detail on this circuit. Right here, since you've already built it, you've already played with it. Giving you details, not a whole lot. What we're going to do in this one, but we want you to do, and we'll show you when we hook it up. You know, the difference that we're doing now is instead of giving you a constant 12 volts like we did last time, we want you to play with this variable voltage and see how much just changing that voltage changes how the circuit behaves.
Right.
So give us just a moment, guys. We're going to reset where you can see our trainer box, and we will hook it all up, turn it on, and hopefully we don't set anything on fire.
Right.
You know, I mean, we don't have any fire extinguishers in here, I don't think. I mean, we've got Monster, but, you know, I don't know how well Monster, We don't want sugar all over our board. That stuff's just be horrible to try to wipe up, you know?
Right.
All right, guys, we'll be right back. All right, guys, we're back. And as you can see, we've pretty much, well, we've built the two sections of the circuit already. But before we go too far into it and finish up, we wanted you to see what you should be looking at before you put all of the components together. So one thing to help you along real quick is remember how I said everything has to have the same common ground. Well, that's what we have to do here as well. So we have to make sure that when we build this thing, that we build it the right way.
Right. So what this wire is doing here is pretty much connecting these two columns here with the same ground. So once we connect one ground to either one of these rows here on the column, sorry, then actually both of these will act as the same ground. Okay, which makes it easier for your circuit construction.
Yep. So right here we're going to go ahead once again put our function generator in this place. We're not going to hook up our battery just yet. We'll show you in just a minute how we're going to hook up the battery. We do, however, need to tie our grounds together, and we'll do that in just a moment. Real quick, what we want to show you is we want to start out with about 9 volts on our variable on this V+. If you look at this V+ right here, and you'll see where I plugged in this black wire, it's up here at this V+. Plug that in. Grab your handy dandy little digital multimeter. You're going to put it on voltage right here. And you'll see it pop up and give you a few numbers starting out. I'll have Aspen hold that for me while I put the black to the ground. Voltage meters, when you're measuring DC voltage, are polarity sensitive. Put my red to right there. Turn on my box. And right there you're looking at about 11 volts. So we're going to knock that down to 9 volts starting out. And then we're going to play with it throughout the experiment. So 8.92 is good enough for government work, so that's where we're going to leave it at right quick. Shut that off. Make sure you turn your multimeter off. It will drain the battery. So now we're going to go ahead and turn this back off. As long as you don't touch the knob, it will stay right where that voltage was at without any problem. Let's see here. Now it's time to hook up our handy dandy little solar cell. All right.
Our solar cell, again, is acting as our input for our amplifier, right? So what that means is we're going to actually hook up the positive side, which is the red part of our solar cell here, in series with our capacitor. Remember, our capacitor was our first input point of our amplifier, so that's what we did here. Okay. Then our ground of our solar cell is going to go straight to ground, as we need all our circuits to be grounded to work properly. Okay.
Next step, I know you got a lot of hands going on right here, but our next steps, again, we're going to take our red wire, connect it to the output of our amplified circuit. Let's give that wire a good wrap, and then take the negative side and connect it to the negative pole.
Right.
And there again, sorry about that. Get a good wrap, and now your speaker's in place. So now we're going to take our variable voltage and we're going to plug it into this positive rail up here, little plus rail of our breadboard. So that will give us our positive voltage for our entire circuit. Oh, one more thing before we get going too much further into this is to connect our DC, our negative, or the ground over here, to the ground of right here. We will do that like so. And connection is made. So now we're going to take our battery Our nice little cool little 9-volt battery. Very simple.
Right.
We're going to take our positive lead. We're going to go here. We're going to take our negative lead, and we're going to connect it to our LED, and bingo. You should see a nice, pretty white light. So with all that done, we're going to start at a simple 100 hertz. If you, in your first experiment, my apologies, in experiment number 2, 100 hertz, if you started out there, you probably couldn't hear a whole lot of it. So let's hope that in experiment 3, you hear something out of it. Okay, got our equipment issue fixed. So now, here's what we're going to start at. We're going to start at 100 hertz. And you didn't hear much. So now you're hearing something? I'm going to hold the speaker closer to my mic.
As you can tell, adjusting our biasing voltage or our X voltage, the more it decreases it, the softer the sound is. But as it increases, the amplitude of the output sound is increased. Going to 1 kilohertz, and you can see it's more of a high. It's a high pitch. It's higher pitched frequency here. As you can see here, as it decreases, increases the frequency, the pitch is higher or lower. And that's probably not pleasant. Okay. This is our about a 10K frequency here, very high pitch.
You may or may not be able to hear it. The microphone may or may not be able to pick it up. But rest assured, when you're in the lab, you're going to hear it, and you're going to know it.
Of course.
All right, let's get off the 10 kilohertz for a moment. Better.
So again, guys, what this is doing is that this taking this function generator input and passing through the circuit. This light is actually is shining onto the solar cell. The solar cell is capturing the electrons. Okay. The photons going into the solar cell is actually being captured and is going into the circuit as a current with the audio signal being carried along with it. And that's what you're hearing now, because now you can actually hear it because it's going to that we construct experiment 1, and you can hear it very well via the speaker. Okay.
So guys, by all means, take you a couple of minutes and play with it. Yeah, go ahead. See how far away you can get the solar panel before you lose sound quality. And with our little shorty wires, even from at the length of our wires, we're still getting a really good sound out of it.
Right.
So, of course, you turn it to the left or right, you break that line of sight with the solar panel, and you're going to lose your audio sound. So by all means, guys, play with your voltage, play with your V+, play with your frequency generator. See what a sawtooth wave sounds like. See what a square wave sounds like. It's pretty cool, isn't it? So you won't hear that much of a difference because of, again, the cutoff. But go ahead, play with it, guys. Have fun. We're going to stop right here on the experiment, and we'll be right back for setup and for questions.
Right.
All right, guys. We'll be back.
All right, guys. So we're back. So we had a lot of fun with that experiment, actually. You can do a lot of cool different sounds and whatnot based off of your voltage and your frequency. I'm sure you're aggravating your instructor by now. But yeah, guys, like I said, hope you had a lot of fun.
We certainly did.
Yeah, we had a lot of fun. Okay, maybe too much. But again, safety first, as always. When you're doing this experiment, make sure that your box is off before prior to putting all the components into your circuit board and then turning it on.
And during any changes they have to make, please turn everything off,
Please
disconnect
turn it
all power supplies, the whole 9 yards.
Yeah, definitely. But if you have any questions, please refer back to your lab manual. Again, it will have the full theory behind how the LED and solar cell works to turn light to electricity, as well as all of the mathematics behind it as well and whatnot. Or refer to us. You can please leave a comment below. We'll be happy to answer any questions you may have, or any critiques that you would have for us or something like that. Please let us know. We're always happy to improve our videos and our education curriculum for you guys. Okay?
Yep. After all, we're here for you. So also you'll see in experiment 3s where we've got it set up where as you increase the voltage, the biasing voltage, how much it changes your amplification. Why exactly is it that happens? But yeah, I mean, I'm happy with where we're at right now.
Oh yeah, definitely. Likewise.
Hopefully y'all are happy with where y'all are at right now. Hopefully y'all enjoyed it.
Right. And with these 3 experiments, this is definitely not all you can do with this product here, with this box. You can do a whole lot more. Okay. It's almost endless, really, the amount of experience and type of outputs and whatnot that you can create. All that cool stuff. So please, I hope this at least sparks your interest of what engineer is and why math is so cool, right? We want to make sure that you're having guys a lot of fun with math and how you can apply it to experiments such as this one.
Yep. So, all right, guys. Thanks once again. Go ahead and like our channel. Please subscribe. Donate. We're just kidding.
No,
but no, just give us good constructive feedback one way or the other so we can help you all out and make our videos better, our experiments better for you.
Of course.
Yeah, we're out.
Have fun, guys.